привет! Сегодня расскажу про новую outbound стратегию, то есть холодную рассылку, которую я нашел на Reddit. Я ее не буду использовать, потому что мой cold calling, мой английский не самый лучший для общения, и я больше вывожу своим изображением, но вы можете попробовать, и действительно неплохая стратегия, поэтому стоит послушать. Во-первых, это стратегия на high volume. Мы делаем coffee before, то есть мы общаемся с человеком по телефону. Сначала по телефону до лума, до зума и до продажи. И после этого мы садим ему персонализированный план. Первое, что мы делаем, да, то есть нужно, конечно же, весь момент такой, что не нужно быть роботом, да, то есть во всей email рассылке
Hi everyone. So I've wanted to make this video for a while. It is a comprehensive but general audience introduction to large language models like ChatGPT. And what I'm hoping to achieve in this video is to give you kind of mental models for thinking through what it is that this tool is. It is obviously magical and amazing in some respects. It's really good at some things, not very good at other things, and there's also a lot of sharp edges to be aware of. So what is behind this text box? You can put anything in there and press enter, but what should we be putting there, and what are these words generated back? How does this work, and what are you talking to exactly? So I'm hoping to get at all those topics in this video. We're going to go through the entire pipeline of how this stuff is built, but I'm going to keep everything accessible to a general audience. So let's take a look at first how you build something like ChatGPT, and along the way I'm going to talk about some of the sort of cognitive psychological implications of these tools. Okay, so let's build ChatGPT. So there's going to be multiple stages arranged sequentially. The first stage is called the pre-training stage. And the first step of the pre-training stage is to download and process the internet. Now, to get a sense of what this roughly looks like, I recommend looking at this URL here. So this company called Hugging Face collected and created and curated this data set called Fine Web. And they go into a lot of detail in this blog post on how they constructed the Fine Web dataset. And all of the major LLM providers like OpenAI, Anthropic, and Google, and so on, will have some equivalent internally of something like the Fine Web dataset. So roughly what are we trying to achieve here? We're trying to get a ton of text from the internet, from publicly available sources. So we're trying to have a huge quantity of very high quality documents. And we also want a very large diversity of documents because we want to have a lot of knowledge inside these models. So we want large diversity of high quality documents, and we want many, many of them. And achieving this is quite complicated, and as you can see here, it takes multiple stages to do well. So let's take a look at what some of these stages look like in a bit. For now, I'd like to note that, for example, the Fine Web dataset, which is fairly representative of what you would see in a production grade application, actually ends up being only about 44 terabytes of disk space. You can get a USB stick for like a terabyte very easily, or I think this could fit on a single hard drive almost today. So this is not a huge amount of data at the end of the day. Even though the internet is very, very large, we're working with text, and we're also filtering it aggressively. So we end up with about 44 terabytes in this example. So let's take a look at kind of what this data looks like and what some of these stages also are. So the starting point for a lot of these efforts, and something that contributes most of the data by the end of it, is data from Common Crawl. So Common Crawl is an organization that has been basically scouring the internet since 2007. So as of 2024, for example, Common Crawl has indexed 2.7 billion web pages, and they have all these crawlers going around the internet. And what you end up doing basically is you start with a few seed web pages, and then you follow all the links. And you just keep following the links, and you keep indexing all the information, and you end up with a ton of data of the internet over time. So this is usually the starting point for a lot of these efforts. Now, this Common Crawl data is quite raw and is filtered in many, many different ways. So here they document, this is the same diagram, they document a little bit the kind of processing that happens in these stages. So the first thing here is something called URL filtering. So what that is referring to is that there's these block lists of basically URLs that are, or domains that you don't want to be getting data from. So usually this includes things like malware websites, spam websites, marketing websites, racist websites, adult sites, and things like that. So there's a ton of different types of websites that are just eliminated at this stage because we don't want them in our data set. The second part is text extraction. You have to remember that all of these web pages, this is the raw HTML of these web pages that is being saved by these crawlers. So when I go to inspect here, this is what the raw HTML actually looks like. You'll notice that it's got all this markup, like lists and stuff like that, and there's CSS and all this kind of stuff. So this is computer code almost for these web pages. But what we really want is we just want this text, right? We just want the text of this web page, and we don't want the navigation and things like that. So there's a lot of filtering and processing and heuristics that go into adequately filtering for just the good content of these web pages. The next stage here is language filtering. So for example, FineWeb filters using a language classifier. They try to guess what language every single web page is in, and then they only keep web pages that have more than 65% of English, as an example. And so you can get a sense that this is like a design decision that different companies can take for themselves. What fraction of all different types of languages are we going to include in our data set? Because, for example, if we filter out all of the Spanish, as an example, then you might imagine that our model later will not be very good at Spanish because it's just never seen that much data of that language. And so different companies can focus on multilingual performance to a different degree, as an example. So FineWeb is quite focused on English. And so their language model, if they end up training one later, will be very good at English, but not maybe very good at other languages. After language filtering, there's a few other filtering steps and deduplication and things like that. finishing with, for example, the PII removal. This is personally identifiable information. So as an example, addresses, social security numbers, and things like that, you would try to detect them and you would try to filter out those kinds of web pages from the data set as well. So there's a lot of stages here, and I won't go into full detail, but it is a fairly extensive part of the pre-processing, and you end up with, for example, the Define Web Dataset. So when you click in on it, you can see some examples here of what this actually ends up looking like, and anyone can download this on the Hugging Face webpage. And so here's some examples of the final text that ends up in the training set. So this is some article about tornadoes in 2012. So there's some tornadoes in 2012 and what happened. This next one is something about, did you know you have 2 little yellow 9-volt battery-sized adrenal glands in your body? Okay, so this is some kind of a odd medical article. So just think of these as basically web pages on the internet filtered just for the text in various ways. And now we have a ton of text, 40 terabytes of it. And that now is the starting point for the next step of this stage. Now, I wanted to give you an intuitive sense of where we are right now. So I took the first 200 web pages here, and remember we have tons of them, and I just take all that text and I just put it all together, concatenate it. And so this is what we end up with. We just get this just raw text, raw internet text. And there's a ton of it, even in these 200 web pages. So I can continue zooming out here. And we just have this like massive tapestry of text data. And this text data has all these patterns. And what we want to do now is we want to start training neural networks on this data so the neural networks can internalize and model how this text flows, right? So we just have this giant texture of text. And now we want to get neural nets that mimic it. Okay, now before we plug text into neural networks, we have to decide how we're going to represent this text and how we're going to feed it in. Now, the way our technology works for these neural nets is that they expect a one-dimensional sequence of symbols, and they want a finite set of symbols that are possible. And so we have to decide what are the symbols, and then we have to represent our data as a one-dimensional sequence of those symbols. So right now what we have is a one-dimensional sequence of text. It starts here and it goes here and then it comes here, etc. So this is a one-dimensional sequence, even though on my monitor, of course, it's laid out in a two-dimensional way, but it goes from left to right and top to bottom, right? So it's a one-dimensional sequence of text. Now, this being computers, of course, there's an underlying representation here. So if I do what's called UTF-8 encode this text, then I can get the raw bits that correspond to this text in the computer. And that's what that looks like this. So it turns out that, for example, this very first bar here is the first 8 bits as an example. So what is this thing, right? This is a representation that we are looking for in a certain sense. We have exactly 2 possible symbols, 0 and 1, and we have a very long sequence of it, right? Now, as it turns out, this sequence length is actually going to be a very finite and precious resource in our neural network. And we actually don't want extremely long sequences of just 2 symbols. Instead, what we want is we want to trade off this symbol size